Yes, hello everyone. Good evening to all of you guys, and welcome on YourPedia platform. Guys, as you know, we have started this particular module for HPCL. Okay, and already some of the classes were conducted in last week also, and yes, this week also you will have some of the classes on YouTube. Mostly classes will be on YourPedia panel. If you will join us, you will find lots of classes in next month on next week, starting from 19th of March. We are starting all classes, mostly classes on Zoom only. So yes, so guys, let's start our today's discussion. And last discussion, we studied about basic terms, basic terminology related to thermodynamics, guys. And in this class, we will start with zeroth law and zeroth law of thermodynamics. Yes, and the basic things related to Gibbs phase rule. Okay, so what do you mean by phase? What do you mean by DUF? How we define DUF for a critical point, for a triple point? Okay, what do you mean by homogeneous substance? All these things we are going to study. So first, I will start with the zeroth law of thermodynamics, and I will introduce you what do you mean by temperature and how actually we measure temperature. Okay, what is the process of temperature measurement, how a thermometer works, how a thermistor works. Okay, what do you mean by resistance thermometer, what is constant volume thermometer, what is constant pressure thermometer, how we measure all these things. Yes, Sandeepan, thank you. Yes, good evening everybody. Bhanu, Ashish, Gaurav, thank you. So guys, let's start our today's discussion. So let me first introduce you this particular thing, zeroth law of thermodynamics. Very simple thing actually, which is mostly asked in interview. Okay, and people generally say, sir, body A in equilibrium with B, body B in equilibrium with B, and they generally define this law like this. Okay, this is not the way actually, guys, to define zeroth law. Okay, because this is very simplest thing. Like if you mention anywhere, because most of the mechanical engineer, 90% of mechanical engineer mention thermodynamics as their favorite subject. So what are the important questions from that? What is zeroth law, what is first law, what is second law? Or people generally define it like that. But what is temperature? That we know, guys, temperature, concept of temperature is not given by the zeroth law. Okay, concept of temperature measurement is given by temperature law. Even before this law, we know the how to measure temperature, but we don't know the portable means of temperature measurement. Means, we if we want to measure the temperature before the existence of this law, what we need to do at that time, we need to bring the body into the lab, then only we will be able to measure the temperature. But after giving this particular law, we able to understand, like, now we can measure temperature anywhere in universe without bringing the body into the lab. Like, suppose if you want your MRI scan, or if you want your X-ray, okay, is it possible at your home? No, it is not possible. Like, if you want your MRI or a CT scan or some type of blood test, what do you need to do? You need to bring the sample or that object into the lab, then only you will get the desired reading. Getting point? But for temperature measurement, after this particular law, we can measure temperature anywhere. How we can measure? That is the thing that you need to understand. So zeroth law of thermodynamics, it gives us the portable means of temperature measurement. इसने हमें क्या दिया? Portable means. Portable means of temperature measurement. अब इसका मतलब क्या है? Portable means of temperature measurement. Okay, what do you mean by this? अब इसका मतलब क्या है? Now if you remember this, then there is no need further to say कि sir body A is in equilibrium with, it is not actually required. If you say, sir, zeroth law gives us the portable means of temperature measurement, what is the meaning of this? Like, we can measure anywhere temperature, we can measure temperature, we can measure, we can measure anywhere, okay, without bringing, without bringing, just a minute, okay, without bringing, चलो इसको यहां लिख देते हैं, without bringing the body into the lab. Okay, into the lab. So this is given by this. So now you can say that Now you can say that how we are actually measuring the temperature without bringing the body into the lab. Now then you can mention that, okay, sir, if we are having three bodies, if we are having three bodies like this, suppose this is body A, this is body B, and this is body C. Okay, so we are having three bodies. Okay, here this A is known as the lab body. इसको मैं क्या बोल रहा हूँ? This is known as lab body. Okay, or experimental body, lab body or experimental body. Okay, what is this? See, this is your test body. This is your test body. Test body, it may be a machine, it may be any person. It is a place where you want to measure your temperature. Okay, this is the place where you want to measure your temperature. Okay, so now if you want to measure the temperature of this body C, it is not required to bring this C close to A. That is a beauty, that is a concept actually which was given by zeroth law of thermodynamics. Okay, if you want to measure the temperature of C, it is not required to bring C close to A. Without bringing C close to A, you can measure its temperature. How you can measure? So for that, what you can do, like this B is known as thermometer. This is your thermometer. This is thermometer. Okay, and this B is calibrated with A, guys. This is calibrated with A. इसे बोलते हैं हम calibration. This is calibration, calibrated. Okay, this B is calibrated with A. Okay, now we know if we are having some this much of the height rise, mercury rise of the thermometer, this is the temperature. If this is the height rise, this is the temperature. If this is the EMF we are getting, this is the temperature. Okay, so we calibrated this B with A. Okay, now if you will just bring the C in close to A separately, this C, if we will bring close to A, B separately, we can say that B and A and C are in thermal equilibrium. Without bringing C close to A, we can say C is in thermal equilibrium with B. That we can say. Okay. So what is the definition of this particular law? What is the definition of this law? So what you can say, there are three bodies which we can consider A, B, C. A is known as your experimental body or lab body. B is your thermometer and C is your test body. So zeroth law of thermodynamics states that if B is in individually thermal equilibrium with A separately and it is also in thermal equilibrium with C separately, then you can say कि A and C are also in thermal equilibrium with each other without bringing A and C close to each other. So that is a law, that is a concept which is given by zeroth law of thermodynamics. Okay, so how we measure temperature? We measure temperature like by calibration of this temperature measuring devices. So there are different type of temperature measuring devices. If I will represent here, guys, if I will write here different type of temperature measuring devices. Okay, temperature measuring devices. Okay, there are different type of temperature measuring devices. Like suppose if I will write here thermometer, thermometer. Okay, thermistor. Okay, thermocouple. Okay, and constant volume gas thermometer. Constant volume gas thermometer. Okay, constant volume gas thermometer. Okay, similarly there is a constant pressure gas thermometer also. Constant pressure gas thermometer. Okay, so these are the different type of thermometer which we are having. Tabu Gaji, for that you need to check the qualification. Okay, at this time I don't know like whether EC students are eligible or not. I think these vacancies are mostly for mechanical, but you can check. I cannot assure you about that. If you will check the notification, you will find ki EC students are eligible or not. Okay, so there are different type of temperature measuring devices: thermometer, thermistor, thermocouple, constant volume thermometer, and constant pressure thermometer. So guys, what we are doing? Okay, we are just choosing a temperature measuring devices and we are fixing one of the thermometric property. क्या fix कर रहे हैं हम? Thermometric property. Okay, thermometric property we are fixing. What do you mean by thermometric property? The property of a thermometer, the property of the temperature measuring devices, which will vary with the change in temperature. Okay, so we are identifying some of the property which is actually changing with the change in temperature. Okay, and we are measuring the change in that property to measure the change in temperature, guys. So what if anybody will ask you, what is a thermometric property? What do you mean by thermometric property? So it is that property which varies with the change in temperature, which varies actually with the temperature. Okay, so if there is a change in temperature, that property will vary. And we are not directly measuring the temperature, we are measuring the change in that property. Okay, by measuring the change in that particular quantity or property, we are measuring the change in the temperature. Okay, like in thermometer or simple mercury thermometer, किस तरह का thermometer? Mercury thermometer. Okay, in mercury thermometer, what is the thermometric property? The thermometric property is the length or volume. Okay, so length or volume is a thermometric property. So what we are doing, when there is a change in temperature, the mercury present in the bulb of a thermometer, that expands, because that is a property of mercury. It expands when there is a change in temperature. When temperature of the mercury bulb rises, the mercury will expand, and when it will expand, we actually restricted its area. Okay, so we don't allow to mercury to expand in that volumetric direction. We generally, we simply allow it to expand in the this particular lengthwise only. Okay, so what we are actually observing, we are observing the change in height of the mercury level inside the thermometer when there is a change in temperature. So guys, actually we are not measuring temperature, we are measuring the rise in height of the mercury. Okay, we are not measuring temperature. But how we can say that if this is the height rise, this is the temperature? How we can say that? Because that height rise is calibrated with the lab body, guys. This you need to understand. Okay, actually we are measuring the height rise only, but by measuring the height rise, we can say this is the temperature. Why? Because we calibrated that height rise with the lab body, guys. Like suppose you are having thermometer and you actually tested what is the height rise at 0 degree Celsius, what is the height rise at 100 degree Celsius, and how actually 0 and 100 are fixed. How? Because these are not, you can say कि sir कहीं भगवान ने हमें दे दिया कि this is 0, this is 100. We defined the ice point, like Kelvin. If you will go through, if you will go with Kelvin scale. Okay, so it actually defined. Okay, or degree Celsius. If I will first talk about degree Celsius, okay, scale. So in degree Celsius scale, we generally define ice point at 0 degree Celsius and steam point at 100 degree Celsius. So we defined all those ice point and steam point, and they are not fixed, guys. You cannot say his ice point is 0, a steam point is 100. This is actually the incomplete definition. When you are saying 0, so you need to mention 0 degree Celsius, because ice point and steam point, they are different in different temperature scales. Like we are having different temperature scale. We are having Kelvin scale, we are having degree Celsius scale, we are having Fahrenheit scale, we are having Rankine scale, guys. There are lots of types of temperature scale. Okay, yes, Sanket, good evening. So we are having different type of temperature scale, and what you need to understand, guys, temperature scale are random. Okay, you can develop your own temperature scale also. Like suppose, sir, if I will give you an opportunity, you can fix, sir. I want to fix ice point as suppose your name, like last comment is from Sanket Pandey. So Sanket want to develop some temperature scale, and he is saying, sir, I want to fix ice point at minus 50 degree SP. Why? Because his name is SP, Sanket Pandey. So he want to fix the temperature scale ice point as minus 50 degree SP, and he want to fix the steam point as a 200 degree SP. So he can develop his own temperature scale also by keeping these ice points and steam points. Getting my point, guys? So what you need to understand, temperature scale are random. You can develop your own temperature scale. But yes, why there are different temperature scale? Why not single temperature scale? Like suppose you can answer why there is a Fahrenheit scale when there is already a degree Celsius scale. Why there is Fahrenheit scale, guys? Very small temperature change. If you want to observe, you can observe very critically, very you can say clearly in degree Fahrenheit scale. You cannot observe that small change in temperature with degree Celsius. Why? Because suppose if there is temperature change from 37 degrees Celsius to 38, or 37 degrees Celsius to 37.5, you will say there is only zero point 0.5, and sometimes we read 37.5 also as 37 only. Yes or no? So 37 and 37.5 both are like, they look like similar. Okay, but they are not same, guys. They are not same. Like if you will go into the Fahrenheit scale from 37 to 37.5, you will find there will be passes of 3-4 units, means 38 to 100, you can say. Okay, 98, sorry, 98 to 100. So if you want to measure very small changes, and the temperature changes same, guys, actually temperature changes same, but the representation of that temperature change is different. Getting a point? So if you, because like when, if suppose any person is having fever and you are saying, if he is having fever, the temperature is 37.5, and if he is not having fever, you will say the temperature is 37. Both looks like similar. Okay, but if you will represent on a degree Fahrenheit scale, you will say, sir, 98, 99, 99.5 ho gaya sir, bahut zyada bukhar ho gaya. Getting point? So that's why there are different type of temperature scale that you need to understand. Similarly, there is a Rankine scale. Why there is a Kelvin scale? Because in Kelvin scale you are not having a negative scale. Kelvin में negative नहीं होता, because Kelvin scale is known as absolute scale. Kelvin scale will always be positive. Why? Because what is absolute Kelvin? Absolute Kelvin is 0 degree, 0 degree Kelvin. Okay, and below the 0 degree Kelvin, the temperature is not possible. Even we cannot attain, we cannot achieve 0 degree Kelvin. Okay, so Kelvin scale is developed because we can represent temperature in one direction only, because a negative temperature scale is not possible in Kelvin scale. Similarly, in Rankine scale is also a positive scale. In that Rankine scale also, we are not having any negative Rankine scale. Okay, means -1 degree Kelvin, that is not possible, because 0 degree Kelvin is not achievable. That you know. Okay, so let me now enter into this particular thing. Zeroth law I introduced you. Thermometric property I introduced you. What is the thermometric property? That is actually varying with the change in temperature. So in mercury thermometer, you can say volume or length. Okay, let me write here volume. Okay, or length is the thermometric property. सिमिलरली थर्मिस्टर को जो बोलते हैं, इसे बोलते हैं रेजिस्टेंस थर्मामीटर. क्या बोलते हैं? रेजिस्टेंस. थोड़ा थोड़ा ब्रीफ में बताऊंगा हाउ एक्चुअली दिस थर्मामीटर वर्क्स. ओके, आई विल टेल यू दैट आल्सो. सो थर्मिस्टर में थर्मामेट्रिक प्रॉपर्टी इज रेजिस्टेंस. ओके, इसके बोलते हैं रेजिस्टेंस इज द थर्मामेट्रिक प्रॉपर्टी. इसको बोलते हैं रेजिस्टेंस थर्मामीटर. Thermistors are also known as resistance thermometer. Similarly, in thermocouple, EMF or voltage is the thermometric property. EMF or voltage is the thermometric property. Similarly, in constant volume gas thermometer, guys, just remember this: constant volume. So if volume is constant, what will change? If you are keeping volume constant, what will change, guys? You want to measure the temperature, volume you are keeping constant, so what will change? The pressure will change. So what you are measuring? You are measuring the change in pressure. If you want to measure the change in temperature, you need to measure the change in pressure. That's why the pressure is a thermometric property, guys. The pressure is the thermometric property for constant volume gas thermometer. Similarly, for constant pressure gas thermometer, you are keeping pressure constant. Okay, so what you are measuring? You are measuring the change in volume. So volume is the thermometric property. वॉल्यूम क्या हो जाएगी आपकी? थर्मामेट्रिक प्रॉपर्टी. सो फर्स्ट थिंग, दिस यू नीड टू रिमेंबर. For what type of thermometer, like thermistor, thermometer, thermocouple, constant volume gas thermometer, what is the thermometric property? That's the first thing which you need to remember. Okay, okay, let me move to now second part, and that is more interesting. Let me show you some of the things, like okay, let me first show you the okay, let me first show you the thermocouple. Okay, let me first show you the thermocouple. Okay, so thermocouple, as I mentioned, in thermocouple, EMF or voltage is the thermometric property. EMF or voltage is the thermometric property. Okay, is thermometric property. Okay, so how it works and what is the principle of this thermocouple? What is the principle of thermocouple? Okay, so thermocouple works on the principle of Seebeck effect. किस पे काम करता है? It works on Seebeck effect. देखो छोटी छोटी चीजें हैं जो आपको पता होना चाहिए. Okay, Seebeck effect. Okay, so what this Seebeck effect tells us, guys? Physics में हमने पढ़ा है बहुत पहले. Just you can recall that. So you can say, sir, if we are having two dissimilar metal like this, these two dissimilar metal you are having, this is wire A, wire B. So these are two dissimilar metal. Okay, and you joined these two dissimilar metal such that you formed two junctions. आपने इन दो dissimilar metal wires को join किया, and now you are having two junctions. This is one junction, this is second junction. This you are saying this is a cold junction actually, because you are not changing temperature here, and this particular junction is known as a hot junction because here you are changing the temperature. Okay, so what Seebeck effect tells us, like if you joined two dissimilar metal wire in such a way that you formed two junctions, and if you are maintaining the temperature difference between those two junctions, then some EMF will set up between that two junctions. Okay, and that EMF setup is directly proportional to the temperature difference. Okay, so larger the temperature difference, larger will be the EMF. Okay, that information we are getting from the Seebeck effect, guys. Okay, so the temperature difference is more, the EMF produced will be more. Okay, that's why we are utilizing this Seebeck effect. Okay, and we developed some instrument that is known as a thermocouple. And what we are measuring, guys, we are measuring the EMF. Okay, so if temperature difference is small, the EMF produced will be small, and if temperature difference is large, the EMF produced will be large. And this EMF produced we have calibrated, इसको हमने क्या कर दिया, calibrate कर दिया. ओके इसको हमने क्या कर दिया, कैलिब्रेट कर दिया. हाउ, लाइक सपोज इफ यू आर हैविंग सम माइक्रो वोल्ट, मान लीजिए इतना वोल्ट मिला, मान लीजिए आपको इतना वोल्ट मिला, सो व्हाट यू कैन से, द टेम्परेचर इज दिस मच. इफ यू आर गेटिंग सम वोल्टेज 0.005 volt, you can say the temperature is this much. Okay, so we calibrated this voltage with what, the temperature. Okay, so that thing we already calibrate, that all task, all work we already carried out in what, where, lab. Okay, so now anywhere you want to measure the temperature, what you need to measure, you may need to measure the voltage only. Like there are two, like generally if you will go to the market, you can purchase this thermocouple in only 50 to 100 rupees only, guys. This is not a very costly device. But if you want a digital thermometer, then it is costly. Why? Because in normal thermocouple, even you will be able to purchase less than 50 also, because thermocouple is a very simple device. Okay, because if you don't go for digital thermometer, then what you need to do, you need to measure the voltage. Okay, and you will get a calibrated, you can calibrate that thermometer also. Like if you will purchase a thermocouple, sorry, if you will purchase a thermocouple from market, first you need to calibrate that thermocouple by what voltage you are getting at 0 degrees Celsius, what voltage you are getting at 100 degrees Celsius. You need to carry out that calibration. Okay, but if you purchase a digital thermometer, then you need to do like any work related to that. Directly you will get a reading in some digital meter will be there. Okay, and directly you will get reading like this 50.007, like this degree Celsius. So in digital thermometer directly you will get reading. Okay, but in normal simple thermometer it is like that, guys. If you will go to market, you will find a device something like this. Okay, so two junctions, this is solid piece. Okay, solid piece you will get. If you want to you can say explore what is inside, then you can easily purchase this instrument, very simple, very cheap, and then you can find, actually it is very difficult to dismantle this. Why? Because this is actually covered by metallic shell, because a thermocouple needs to bear a low temperature, high temperature also, and for meeting the different physical conditions, we actually covered it in a metallic shell. Okay, and there are two wires, guys, there are two wires, something like that. Two wires will be there. Okay, like this. So similarly, simply if you will attach some voltmeter, you can measure the change in temperature. Okay, so I think this is now clear. What is Seebeck effect? Okay, what is Seebeck effect? This is now clear to you. What is a thermocouple and how it works? The reverse of Seebeck effect, guys, that is known as pyrometer. Satish, pyrometer is used to measure the temperature. Yes, that is a non-contact means of temperature measurement. Non-contact means like you without bringing the temperature measuring devices close to the body. Like suppose if I will give you some laser kind of thing, and just by putting that temperature measuring devices at some distance from the body, you can measure the temperature. Okay, pyrometer is also a temperature measuring devices. Pyranometer is a device which is used for measuring the radiation intensity. Pyranometer हम किसके लिए यूज करते हैं, रेडिएशन इंटेंसिटी को मेजर करने के लिए. पायरोमीटर यूज करते हैं हम टेम्परेचर मेजर करने के लिए विदाउट टचिंग, एक्चुअली विदाउट फिजिकली, विदाउट मेकिंग एनी फिजिकल कॉन्टेक्ट. ओके, हाइग्रोमीटर होता है, ह्यूमिडिटी के लिए यूज करते हैं. ठीक है, हाइड्रोमीटर होता है. ठीक है, देयर आर डिफरेंट लोड्स ऑफ इंस्ट्रूमेंट्स व्हिच वी कैन डिस्कस सेपरेटली. ओके, सो रिवर्स ऑफ सीबेक इफेक्ट इज नोन एज पेल्टियर इफेक्ट. उसे हम क्या बोलते हैं, पेल्टियर. एंड पेल्टियर इफेक्ट वी यूज इन वेयर, फॉर रेफ्रिजरेशन पर्पस. पेल्टियर इफेक्ट को हम यूज करते हैं रेफ्रिजरेशन पर्पस में. रिवर्स का क्या मतलब है? What is the meaning of reverse? Reverse means if you are having two metallic wires, and if you just make there are two junctions, and now if you are providing some EMF, you are providing some EMF between those two junctions, so there will be some temperature difference produced between two junctions. That is known as Peltier effect, that we use in refrigeration. In a refrigeration system, guys, what we want to produce the low temperature, and how we are producing? We are producing by Peltier effect. Now we are giving the voltage, and what we are getting in reverse? What we are getting back? We are getting the temperature difference. In Seebeck effect, we are giving the temperature difference. How we are giving? This is the standard fixed temperature, and this temperature rise we are getting by bringing the thermocouple close to the hot body. Like the temperature, the place where you want to measure the temperature, you are bringing that hot junction into that place. Okay, so you are giving the temperature difference, you are getting the EMF. Okay, so I think this is now clear what is Seebeck effect, what is Peltier effect. I think that is sufficient, guys. You need not to go into further detail. Okay, just remember what is Seebeck effect, what is Peltier effect, how actually we are getting the voltage. Let me now come to next type of thermocouple, next type of temperature measuring devices. Okay, so for that, if I will show you this, okay, let me show you this constant volume gas thermometer. Constant volume gas thermometer. This is another very good important type of thermometer. Constant volume gas thermometer. Constant volume gas thermometer. So guys, what you are doing in this, in a constant volume gas thermometer, what we are doing, we are keeping the volume of the gas constant. Okay, and then we are measuring the change in pressure, and by measuring the change in pressure, we are measuring the change in temperature. So it is something like this, guys. The constant volume gas thermometer is look like this. So there is a bulb, this is known as gas bulb. Okay, इसमें क्या होती है आपकी, इसको हम बोलते हैं, let me show you here. So this is the gas bulb, bulb बोलते हैं हम इसको bulb. Okay, and here some gas is there. Okay, this entire space is filled by gas. Okay, this entire space is filled by gas. Okay, so what you are doing, guys? Sanket, I will come to that, I will come to that separately. So what, how you can measure the temperature, guys? This is a particular bulb. Okay, and this is a capillary tube, something like this, and this is a flexible hose, guys. This hose is a flexible hose, this is not made up of glass. This particular hose is made up of some rubber. Okay, so this particular hose is known as a flexible hose because you can move this edge, this particular limb you can move up and down. Okay, that's why this hose is known as flexible hose. Okay, so how you are measuring the temperature, I will come to that, Remo. I will again I am coming to this how EMF is generated. So what you are doing, guys, when you will just bring this bulb of gas to some hot water. Okay, suppose this is some hot bath or some hot high temperature you are having in this particular container. So when you are bringing this gas into this particular hot water or hot fluid, what will happen? The gas will expand, its volume will change, guys. Gas will expand, its volume will change. So when its volume will change, what will happen, guys? This particular mercury level will go down, guys. Here the mercury level will go down. Okay, and here mercury level will rise. Yes or no? Yes or no? So consider two cases. One case, when this bulb is out from this container. What is the second case? When bulb is inside the hot water, then volume will rise. What will happen? The mercury, this, and in this particular limb, the mercury will go down, and here the mercury will go up. So some head difference will be settled. दोनों के बीच में कुछ difference आ जाएगा. दोनों के बीच में क्या आ जाएगा? Difference. That is actually showing here. The difference will be here. And that H is constant, guys. This H is constant. How you can say that this H is constant? Because the temperature here, the temperature you are considering, that is a constant, and due to that temperature, the volume of gas has changed. Now you will get some H value, and that is constant. So how, for keeping the volume constant, what you will do, you will just raise this limb upward. आप इस लिम्ब को क्या करोगे, इसको थोड़ा और ऊपर उठाओगे, because this particular hose is a flexible hose. Okay, so when you will raise this limb, what will happen, guys? The mercury in this particular left side column, it will rise, and mercury this side will fall. Okay, so you will stop that raising of the limb when this mercury level reach to the initial level, guys. What I'm saying, guys, again just listen very carefully. Okay, that is actually not required, just get this particular information ki how we are measuring the temperature by constant volume or constant pressure thermometer. Okay, so what I'm saying, guys, initially when this bulb is out, there is some temperature, there is some head difference. Okay, there is some head difference, but when you are bringing this bulb into some hot fluid, the mercury will expand, the gas will expand, and the mercury in this mercury will fall, and here the mercury will rise. So some head difference will be settled up here, some height will be there. Oh, that height is constant because you are considering that temperature is constant. Now what you're doing for bringing the mercury to the same level, guys, suppose the mercury initially at this level and now the mercury at this level, what you're doing, you are just raising this particular side of the limb. When you are raising this, the mercury level inside this will rise and here it will fall and mercury will reach to the same level. When mercury will reach to the same level, what you can say the process is constant volume, yes or no, because you are bringing the mercury to the same level by just raising this right side of the limb. What you can say, in constant volume gas thermometer, we are keeping the volume constant by bringing the mercury at the same level with the help of the raising of the right side of the limb. Getting point? So by raising this, you are bringing mercury to the same level. Then what you can say, the volume is same and you are measuring this height rise. You are measuring this height rise, and with the this height rise, you are measuring the pressure change. You are measuring the pressure change, and with the help of the pressure change, you are measuring the temperature change, like this, guys. Suppose if you will consider here the ideal gas, अगर आप यहाँ पे क्या consider कर लो, ideal gas. Okay, if you will consider working medium as an ideal gas, so for ideal gas you can apply ideal gas equation, pv equal to mrt. Okay, so if volume is constant, you can say p by t equal to constant. Okay, p by t equal to constant or c. Okay, so if you will measure the temperature, generally for these type of instrument, guys, the standard temperature which we are taking, that is known as a triple point. Okay, the standard temperature for this is triple point, guys. स्टैंडर्ड टेम्परेचर हम क्या लेते हैं, ट्रिपल पॉइंट. ओके, ट्रिपल पॉइंट. और ट्रिपल पॉइंट भी किसका, ट्रिपल पॉइंट ऑफ वाटर. Triple point of water is a standard fixed temperature. Okay, and triple point of water, you know, that is 0.01 degrees Celsius. 0.01 degrees Celsius, or what you can say, that is 273.16 Kelvin. 273.16 Kelvin. This is a triple point temperature. So if you will measure the PTP, pressure at triple point, temperature at triple point, that is a constant. Okay, that is equal to some constant c. Okay, now if you are bringing some change in pressure, okay, and you want to measure the change in temperature, that you can equate it with what, PTP by TTP. Okay, so you can measure the temperature very easily by measuring the temperature, by measuring the pressure. So temperature you can define like this, P into TTP by PTP. Okay, so this is fixed, this quantity is fixed, guys. The pressure at triple point, the temperature at triple point. What is the pressure at triple point, guys? What is the pressure at triple point? PTP, you know, that is equal to 0.61 Pascal. Okay, kilo Pascal, what you can say, इसको मैं ऐसे लिख देता हूँ, 0.61. Okay, let me write here 60. Okay, 0.61 लिख देता हूँ, चलो 61 Pascal. Close to this you can write. Okay, kilo Pascal मिल रहे हैं तो you can write 0.061 kilo Pascal. Okay, so T equal to P into TTP by PTP. Okay, so this is constant that you know. So just by measuring this pressure, you can measure the temperature. Okay, so temperature is directly proportional to what, pressure. Okay, so this is the equation which we generally use for these type of instruments, constant volume gas thermometer. I think now you are getting this idea what is a constant volume gas thermometer and how we measure the temperature by a constant volume gas thermometer. Similarly, there is a constant pressure gas thermometer also. Yes, you can correct. That's why I'm writing initially it as that's why I'm writing it initially at 0.611 kilopascal. Yes, this is right. 0.611 kilopascal. That's why I'm writing initially like this only. 0.611 kilopascal. Okay, just correct it. Sandeepan, initially, like Sandeepan is asking why we are taking triple point. Like guys, if you will go back in history, you will find before 1954. Before 1954, okay, temperature measurement is based on two fixed temperatures. Temperature measurement was based on two fixed temperature. और वो कौन कौन से थे? दे आर नोन एज स्टीम पॉइंट एंड आइस पॉइंट। वो दो फिक्स टेम्परेचर कौन से थे? स्टीम पॉइंट and ice point. Okay, generally for water only. Means ice point 0 degree Celsius, steam point 100 degree Celsius. Okay, so we generally take these temperature, 2 points, standard points for measuring that temperature before 1954. But yes, there is a international standard, international agencies are there which actually provide the standard of different thing. What is 1 kg, what is 1 meter? Okay, so all these things are carried out by some international agencies. So some meeting conference will was held in this particular year. Okay, and they changed that standard of temperature measurement. And after that 1954, now the all instruments which you are having, they are based on the single fixed temperature. After 1954, instruments which we are having, they are based on single fixed temperature. Single fixed temperature. और वो क्या है अपने आपके पास? That is the triple point of water. Triple point of water. Okay, so we are using this. अब देखो इसी को क्यों यूज करते हैं? You need to take the reference, guys. Okay, you can take reference of anything. Okay, but they have taken the reference of water. Okay, because water and air, these are the substances which are mostly we found. Okay, mostly we deal with actually. Okay, so and we know very easily we defined the ice point and steam point initially also before 1954 also we defined those two fixed temperature for water only, ice point and steam point. After 1954 we defined the single fixed temperature for water. Okay, this is actually a reference they have fixed. Okay, they can fix the reference of any kind, even they can change in future also if they found something more easy or more what you can say relevant or useful, they can change the standard. Like if you will check, like in 2018 or 19 we have changed the standard for mass also. Like initially mass is defined as a mass of some platinum iridium standard, but now the mass is not defined like that. Okay, uh, so generally when the meeting the conference was held, they generally change those standard. Okay, so that is not fixed. So for that particular, you can say, in that particular conference they changed that standard and they fixed the standard fixed temperature as triple point. Okay, that is not actually fixed. In future if something will found more relevant, more useful, they can change that also. Okay, so if you want to define this particular temperature before this 1954, the temperature, linear temperature, the temperature is varying linearly with the temperature, with the pressure, sorry. So you can define temperature as T equal to A P plus B, like this. You can define temperature like this. Okay, and you can write this equation in by two ways. First, by considering the temperature at ice point. Second, by considering the temperature at steam point, like this. So 0 equal to AP plus B. You can say this is the P pressure at where? The pressure at ice point, PI. Okay. Similarly, you can write one more equation: 100 degree, 100 equal to APS plus B. Okay, so we are considering the change in temperature is linearly varying with the pressure. So T equal to AP plus B. 0 means at ice point, 0 equal to API plus B, 100 equal to APS plus B. If you will solve these two equation, guys, अगर आप इसको solve करोगे, you will get the values of A and B. You will get the values of A and B, and then if you will put those values in here, if you will find by solving these two equations, guys, because two unknowns are there, two equations you are having, very easily you can find out the values of A and B. And if you will put those values of A and B here, you will get some temperature variation with the pressure. Okay, so you can find out temperature very easily by measuring the pressure. Okay, but you need not to remember this, guys. You need not to remember this. Only the information which you need to remember, just remember like this, guys. I'm showing you one expression like this. So this I'm showing for degree Celsius scale, degree Celsius. Okay, this I'm showing for degree Fahrenheit. Okay, so just remember this, guys. This I'm showing for ice point, ice point. Okay, and this is steam point. Okay, so conversion, if you want to carry out conversion from degree Celsius to degree Fahrenheit to degree Celsius, or degree Celsius to degree Kelvin or Rankine, if you want to carry out that conversion, just remember in a degree Celsius scale, the ice point is 0 degree Celsius. Ice point क्या होता है? 0 degree Celsius. Okay, and the steam point is 100 degree Celsius. Degree Celsius scale में ice point is 0, steam point is 100 for water, guys. इसके लिए water के लिए. Okay, and uh, in degree Fahrenheit scale, the steam point is 32 degree Fahrenheit, and this is 212 degree Fahrenheit. तो 212 डिग्री फारेनहाइट क्या होता है? दैट इज योर स्टीम पॉइंट इन डिग्री फारेनहाइट स्केल, एंड 32 डिग्री फारेनहाइट इज योर आइस पॉइंट इन डिग्री फारेनहाइट स्केल. ओके. सिमिलरली अगर आपको केल्विन स्केल में लिखना है, केल्विन में अगर किस में लिखना है? केल्विन स्केल. ओके, लेट मी शो हियर केल्विन स्केल. ओके, केल्विन स्केल में यू नो आइस पॉइंट क्या हो जाएगा? दैट विल बी 273.15 केल्विन. 273.15 Kelvin, and here what you will get, guys? 373.15 Kelvin. The steam point is this. Similarly, if you want to show the temperature in Rankine scale, अगर आपको किसमें दिखाना है? Rankine scale में. So in Rankine scale, your ice point is close to 491 degree Rankine. The ice point is close to 491 degree Rankine. Okay, and the steam point here, the steam point is close to 671 degree Rankine. You can check. You can check. Okay, let me change this. ये होगा 691, guys. This will be 691. You can check here, and this is actually close to 471. I think this is close to 471. Okay, you can check. Just check this value and tell me the whether I'm writing right or wrong. Okay, so because you need to remember, not you need not to remember this, guys. Just for your information, I'm writing this only. This is the information which you can remember. Okay, degree Celsius, degree Fahrenheit, and degree Rankine. Varad has actually developed some relationship 1.8 C plus 32. That also you can use directly. So guys, what you need to remember, like suppose if I will give you any temperature, like here, suppose in degree Celsius, I'm saying in degree Celsius you are having some temperature 60 degrees Celsius. Okay, and if I'm asking you, just find the respective value in degree Fahrenheit. Degree Fahrenheit में respective value बताओ. So how to solve this? Just draw this line for degree Celsius and degree Fahrenheit. 0 degree 100, 32, 212. Next, what is the step? Just write here 60 minus 0 divide by 100 minus 0 means 100. Okay, here also write x minus 32 divide by 212 minus 32, you will get 180. So if you solve this, guys, you will get 60 by 100 means simply I'm writing here 60 by 100. Okay, or here you can write 60 minus 0 by 100 minus 0. So you can cut this. Okay, and you can cut this also. So what you will get, guys? 18, if you will multiply by this, you will get x equal to 32 plus 18 multiply by 6. You will get the respective x value here. Okay, you will get the respective x value here. Okay, अच्छा मैंने पहले ठीक लिखा था सही. So मेरे को रक्षित दीपक दीपक बिस्ट, हाँ आई थिंक मैंने पहले ठीक लिखा था 49. यस, इट इज वेरी राइट, वेरी राइटली दीपक यू मेंशन 49.6967, बट दैट इज नॉट, यू नीड नॉट टू रिमेंबर, जस्ट रिमेंबर 491 ओनली, दैट इज सफिशिएंट. ओके, अगर पूरा याद रखने की जरूरत नहीं है. सो दिस इज एक्चुअली राइट, हमने इनिशियली यही लिखा था. ओके, सो यस, दिस इंफॉर्मेशन यू कैन 491 degree Rankine and 471 degree Rankine. Okay, so what I said, guys, just remember this particular two lines. You can carry out conversion. Like suppose if I'll ask you where, at what temperature degree Celsius and degree Fahrenheit scale are equal, can you find out at what temperature degree Fahrenheit and degree Celsius are same? Can you find out, guys? So very simple. What you need to do, guys? Just draw the two lines. Okay, here write what? 0 degree Celsius, 100 degree Celsius. Okay, here write 32 degree Fahrenheit, 180 degree Fahrenheit. Okay, here what you need to write? Here write x. Here also write x. Why? Because we want to find out the temperature where both are equal. If we are interested to find out the temperature where both are equal, write x here, write x here. What is the next step? Write here x minus 0, total length 100 minus 0 is 100. Okay, right here also x minus 32 divided by 180 minus 212 minus 32. What you will get, guys? 180. So if you will solve this, you will get let me write here x by 10 equal to x minus 32 by 18. Okay, so further if you solve this, guys, you will get 18x equal to 10x minus 320. Oh, 320, yes. So further if you solve this, you will get 8x equal to what? 8x equal to minus 320, or you will get x equal to minus 40. So minus 40 degrees Celsius is equal to minus 40 degree Fahrenheit. This just I have shown you. If you want to find out any temperature, guys, okay, where like suppose if I will give you what is the value in degree Celsius at 60 degree Fahrenheit, 60 degree Fahrenheit पे कितना degree Celsius होगा, just you need to remember that. Okay, degree Kelvin के लिए there is no such requirement. Why? Because if you want to convert degree Kelvin in degree Celsius, very simple, because just only you need to remember this degree Celsius, x degree Celsius if you are having, so you can write it as x plus 273.15 डिग्री केल्विन. क्या आ जाएगा, जस्ट ऐड x में क्या ऐड कर दो 273.15, you will get answer in Kelvin. Okay, and if you want the temperature in Kelvin, just subtract 273 from degree Celsius. Okay, अगर आपके पास x किस में है, आपको आंसर चाहिए डिग्री केल्विन में, आंसर चाहिए आपको x केल्विन में, तो क्या करो, जो आपके पास डिग्री सेल्सियस है, डिग्री सेल्सियस में से क्या माइनस कर दो, आंसर इफ यू वांट टू फाइंड आउट इन केल्विन, दिस you want to find out, so just subtract minus 273.15, you will get answer in degree Kelvin. Okay, तो Kelvin या degree Celsius के लिए no such conversion is required, directly you can do. Rankine के लिए also, like if you will find no question was asked related to that, but degree Fahrenheit के लिए वो पूछ लेता है, like वो question ऐसे पूछेगा, suppose you want to develop your own temperature scale, the question will be something like this, guys. You want to develop your own temperature scale, like Ashutosh Tiwari was to develop his own temperature scale, and he wants to keep the ice point as suppose 20 degree 80, Ashutosh Tiwari, and he want to keep the steam point as 200 degree 80. Okay, so Ashutosh Tiwari wants to develop some temperature scale. He is keeping the ice point as 20 degree 80, and he is keeping the steam point at 200 degree 80. Okay, so what type of question can be asked? He can ask you like what temperature in degree Celsius you will get when you are getting when you are having the temperature 50 degrees Celsius. Okay, what reading you will get in the 80 scale? What reading you will get on the 80 scale? Get your point? So if you in thermometer, in mercury thermometer, you are having reading 50 degrees Celsius, so what reading 80 will get? Okay, what reading Ashutosh Tiwari will get? So simple thing, here what you will write 0 degrees Celsius, here you will write 100 degrees Celsius. So what is the question, guys? Again I am mentioning this particular question. The question will be something like this: Ashutosh Tiwari developed some temperature scale and he marked that temperature scale as a degree 80. Okay, and in degree 80 he fixed ice point as 20 degree 80, steam point as 200 degree 80. Okay, and if in mercury thermometer you are having some temperature as a 50 degrees Celsius, what is the corresponding reading you will get on the 80 scale? That is a question. So how to solve? Just write here 50 minus 0, 50 minus 0, 100 minus 0. Okay, suppose here the value is x, suppose here the value is x, so write here x minus 20 by 200 minus 20. Okay, so what you will get, guys? 50 minus 100 by means 1 by 2, 1 by 2 equal to x minus 20 by 180. Okay, so what you will get? 90 equal to x minus 20, means x will come out 110 degree 80. Okay, so when on mercury scale you are getting 50 degrees Celsius, Ashutosh Tiwari will get 110 degree 80. So these type of question can be asked and can be framed from this. Okay, so now what I discussed, guys, what is temperature? Temperature generally in macroscopic form, guys. If I will write here temperature in macroscopic form, temperature क्या है? Temperature macroscopically it is defined as the hotness or coldness of a body. Hotness or coldness of a body. Okay, but this definition is not right, guys, at every place. This definition is not right at all the places. Why? Like suppose if I will give you, suppose in this room you are sitting, okay, and suppose winter condition if you will consider, okay, and suppose we are having two objects, like suppose I'm having some metallic object, okay, I'm having some metallic object here, and I'm having some plastic marker also. So two objects I am having, okay, and when I'm touching these objects, guys, here I'm feeling more coldness, and here I'm not feeling that much, that kind of coldness that I'm feeling by touching this, guys. Okay, so that's why this definition is not right. Why? Because these two bodies are in same environment. Okay, they are placed here from last 2-3 days, so they are in equilibrium condition. So their temperature is very close to the atmospheric temperature. Okay, their temperature is same, but their hotness or coldness are different. That's why this definition is not right here. The temperature is a measure of hotness or coldness. Why? Because every time when you are touching any object, sometime like when I'm giving you some example, the hotness or coldness is different. Generally when you will touch a metallic object in winter, you found that object very cold actually, as compared to the wooden objects. Okay, so that's why we say this is a macroscopic approach, and this is not right. ये right नहीं है. Okay, I told you why it is not right. So in microscopic form में temperature is defined as a kinetic energy of gas molecule. Microscopic form में हम temperature को कैसे divide करते हैं? It is defined as a kinetic energy of gas molecule. Kinetic energy of gas molecules. Okay, so we define temperature as a kinetic energy of gas molecule. And last class, guys, I introduced you this particular expression. You remember? Kinetic energy of gas, ideal gas, guys, that is equal to F by 2 RT. तो क्या होती है? Kinetic energy of a gas is directly proportional to temperature. Okay, so larger will be the temperature, more will be the kinetic energy of the gas, guys. Okay, so microscopically temperature is defined as the kinetic energy of gas molecule. Or suppose if any molecule you are having, if it is at high temperature, their molecules will be, they are having more kinetic energy. If the temperature is less, their molecules will have same uh, less kinetic energy. Okay, so if I will take you, like suppose if I will consider two gases, suppose. Okay, now that is a very interesting question. I think you will be able to understand. So if I will give you two gases, guys, two gases if I will give you. Okay, दो गैसेस में देता हूं. इसमें है N2. ओके, इसमें है CO2. यू आर हैविंग टू गैसेस, N2 and CO2. ओके, बोथ आर एट सेम टेम्परेचर. टेम्परेचर इज सेम. टेम्परेचर क्या है? सेम है. ओके, टेम्परेचर क्या है? सेम है. इफ आई विल आस्क यू व्हाट विल बी देयर काइनेटिक एनर्जी, इनकी दोनों की काइनेटिक एनर्जी क्या होगी? यहां पे गैस की काइनेटिक एनर्जी, यहां पे गैस की काइनेटिक एनर्जी क्या होगी? इट विल बी सेम, गाइस. Kinetic energy, suppose this is 1, this is 2. Okay, kinetic energy of 1 will be equal to kinetic energy of 2. That will be same, guys. Kinetic energy of both will be same. Why? Because both are at same temperature. What about potential energy, guys? What about potential energy? That is not same. Why? Because it is made up of, it is having like nitrogen molecule, it is having carbon dioxide, different molecules are there, so their potential energy will be different. Now you can raise your concern, sir, potential energy kahan se aa gaya? Ye to gas hai, ideal gas hai. They are not ideal gas, guys. We treat these gases as an ideal gas, but they are not ideal gas, they are real gases only. They are having some potential energy. So if you are considering these gases as an ideal gas, then what you can say, their potential energy are same and it is equal to 0, guys. This is only true for ideal gas. This is only true for ideal gas, guys. This is not true for real gases. Real gases are not having, the real gases are having potential energy. Okay, and different, if there is a different composition, the potential energy will be different. Like suppose if you will take water and steel, if I will give you two different material, so what do you think? Their potential energy will be same? No, they are made up of different material. Their potential energy will be different. Getting a point, guys? So if you will take two metals, guys, suppose iron and copper. If I am giving you two metal, iron and copper, what you can say? They both are at same temperature. If you are having iron rod, suppose this is iron rod, this is copper rod. If you are having at same temperature, what you can say? The kinetic energy of the molecule will be same. Yes or no? What about potential energy? Potential energy will be different. What about internal energy, guys? Internal energy will be different. Why? Because internal energy of a substance is a sum of what? Kinetic energy plus potential energy. Although these are two material which are at same temperature, their kinetic energy is same, but their potential energy is different. So you cannot say that their internal energy is same. Their internal energy will be different. So internal energy of copper rod, internal energy of steel rod or iron rod, this will be different at same temperature. So at same temperature, two different material, they will have different internal energy. So what I want to say, guys, macroscopic form temperature ये होता है, और माइक्रोस्कोपिक फॉर्म, मैक्रोस्कोपिक पे हॉटनेस और कोल्डनेस होती है, बट दिस इज नॉट राइट एट एवरी प्लेस. पोटेंशियल इंजीनियरिंग नहीं बचे, पोटेंशियल इंजीनियरिंग नहीं, पोटेंशियल एनर्जी. दिस इज पोटेंशियल एनर्जी एंड दिस इज नॉट द बल्क एनर्जी. देखो जब हम एनर्जी की बात करते हैं ना, एनर्जी मैं थोड़ा सा बता के इसको छोड़ दे रहा हूं. ओके, you will find a detailed, very complete detail you will find, like guys, After this class, when you will go to the YourPedia final, you will find a 1 hour, close to 24 minutes detailed lecture on system, surrounding, reversible process, irreversible process, what is energy, what is microscopic form, what is macroscopic form, what is continuum concept. Okay, you will find a detailed lecture on that. Properties kya hoti, intensive, extensive, and if you'll watch that, guys, you will be able to answer all these things. Okay, you will find a PDF also, PDF of entire lecture with that video lecture that is available on panel. So you can watch that also, that will help you actually. Okay, so energy में दो होता है, मैक्रोस्कोपिक एंड माइक्रोस्कोपिक. ओके, मैक्रोस्कोपिक में क्या होती है, काइनेटिक, बल्क काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी. लाइक सपोज व्हेन आई एम सिटिंग इन फ्रंट ऑफ यू, तो मेरी काइनेटिक एनर्जी क्या है, मैं रेस्ट पे हूं, तो मेरी काइनेटिक एनर्जी क्या है, जीरो. पोटेंशियल एनर्जी क्या है, इफ यू आर कंसीडरिंग दिस ग्राउंड एज ए रेफरेंस, तो पोटेंशियल एनर्जी भी क्या है, जीरो. इसे बोलते हैं मैक्रोस्कोपिक फॉर्म. मैक्रोस्कोपिक फॉर्म. माइक्रोस्कोपिक फॉर्म ऑफ एनर्जी जो होती है, इसे बोलते हैं इंटरनल एनर्जी, जो मॉलिक्यूलर लेवल पे होती है. The energy of a substance which lies at the molecular level. Like suppose if I'm taking this body और मैं आपको बोलता हूं कि इसकी मैक्रोस्कोपिक एनर्जी बताओ. मैक्रोस्कोपिक का मतलब इसकी काइनेटिक एनर्जी, बल्क काइनेटिक एनर्जी. मॉलिक्यूल की काइनेटिक एनर्जी नहीं गाइस, मैं क्या बोल रहा हूं, बल्क, बल्क में पूरी बॉडी की इसकी काइनेटिक एनर्जी क्या है, जीरो. बट कैन यू से कि जो इसके अंदर जो मॉलिक्यूल्स हैं, देयर काइनेटिक एनर्जी इज आल्सो जीरो? यू कैन नॉट से, बिकॉज मॉलिक्यूल्स जो अंदर हैं, दे विल बी एट रेस्ट एट अ जीरो केल्विन ओनली. गेटिंग पॉइंट? जीरो केल्विन पे, एब्सोल्यूट केल्विन पे द एनर्जी विल बिकम जीरो. व्हाई हाउ यू कैन से दैट? बिकॉज मॉलिक्यूल्स क्या हो जाएंगे, दे विल केम एट सम स्टैग्नेंट कंडीशन, स्टैटिक हो जाएंगे, वो रेस्ट में आ जाएंगे. गैस हो या कुछ भी हो, क्या किस पे आ जाएंगे, स्टेट में. बट अभी क्या है, दे आर हैविंग सम काइनेटिक एनर्जी, यू कैन कंसीडर. गेटिंग पॉइंट? सो माइक्रोस्कोपिक मींस द एनर्जी व्हिच लाइज एट द मॉलिक्यूलर लेवल. मैक्रोस्कोपिक मींस द एनर्जी व्हिच लाइज एट द बल्क लेवल. तो इसमें क्या आ जाएंगी, काइनेटिक और पोटेंशियल. इसमें क्या आ जाएंगे, इंटरनल. ये वाले जो इंटरनल है, इसमें कौन कौन सी होती है, काइनेटिक एनर्जी ऑफ मॉलिक्यूल, पोटेंशियल एनर्जी ऑफ मॉलिक्यूल, ओके, न्यूक्लियर एनर्जी ऑफ मॉलिक्यूल, ओके, वाइब्रेशनल एनर्जी ऑफ मॉलिक्यूल, बहुत सारी एटॉमिक एनर्जी, जितने भी मॉलिक्यूलर लेवल पे एनर्जी लाई करती हैं, ये सारी एनर्जी जनरली इसमें ये जो एनर्जीज होती है बहुत कम होती है. बिकॉज जो हम कोई भी थर्मोडायनेमिक प्रोसेस विच वी आर कंसिडरिंग, किसी भी थर्मोडायनेमिक प्रोसेस में वी आर नॉट कंसिडरिंग एनी काइंड ऑफ न्यूक्लियर रिएक्शन. Okay, so we are considering a simple thermodynamic process in which there is no nuclear reaction is carrying out. Okay, nuclear reaction नहीं हो रही है. So that's why we generally neglect all those energies. We only consider kinetic and potential energy. Okay, अब जब हम बात करते हैं आइडियल गैस की, तो हम इसको भी neglect कर देते हैं. Why? Because for ideal gas, the intermolecular force of attraction is zero. This potential energy is due to the intermolecular force of attraction. There is a difference, guys. This and this. This is potential energy due to the position of the body. This potential energy is due to the intermolecular force of attraction. If there is no force of attraction between the molecule, the potential energy will be zero. If the if the intermolecular force of attraction is high, the potential energy will be high. Like suppose if I will give you example of water and steel, what do you think, for which case the potential energy will be higher? The potential energy will be higher for steel. Potential energy किसकी हायर होगी, स्टील की. Why? Because in steel there is a strong intermolecular force of attraction as compared to water. So if you are keeping the steel and water at same temperature, स्टील और वाटर आपने सेम टेम्परेचर पे रख दिए, तो ऑब्वियसली द इंटर एनर्जी ऑफ द स्टील विल बी हायर, यू कैन से. Okay, so potential energy क्या है, it is due to the intermolecular force of attraction. For ideal gas this is zero. That's why we only consider kinetic energy as a representation of temperature or as a representation of internal energy. तो ideal gas की जो internal energy होती है, आइडियल गैस के लिए जो इंटरनल एनर्जी होती है, वो सिर्फ काइनेटिक एनर्जी ही होती है. और वो क्या होती है, दैट इज इक्वल टू 3/2 RT. दैट्स व्हाई वी से इंटरनल एनर्जी ऑफ एन आइडियल गैस इज ए फंक्शन ऑफ टेम्परेचर ओनली. ओके, आइडियल गैस की जो इंटरनल एनर्जी होती है, वो किसका फंक्शन होती है, इट इज ए फंक्शन ऑफ टेम्परेचर ओनली. ओके, सो व्हाट इंफॉर्मेशन यू कैन राइट हियर गाइस, आइडियल गैस थर्मामीटर का जो टेम्परेचर है, इट इज इंडिपेंडेंट ऑफ मटेरियल. Ideal gas thermometer temperature is independent of the material. वो material पे depend नहीं करता, it depends on the temperature only. Okay, it is independent of the construction पे depend नहीं करेगा, material पे depend नहीं करेगा, it depends on the temperature only. Okay, so let me now write here some of the question. Okay, so we discussed something about temperature measurement, guys. What is temperature? Okay, what is zeroth law? Temperature measurement कैसे करते हैं, thermometric property का हमने कुछ introduction लिया. Okay, now let me discuss with you guys one more thing, Gibbs phase rule. Let me discuss here Gibbs phase rule. thoda sa humne slightly we discussed this particular thing in last class also, but here I'm discussing this in detail. F plus P equal to C plus 2. This is the phase rule, Gibbs phase rule, which was given by this particular person. Gibbs is some researcher. Okay, you know, not to go into that detail. What is the complete name of that? This particular scientist. So this is a Gibbs phase rule. F plus P equal to C plus 2. What is this F, guys? This is known as a DOF. इसे हम क्या बोलते हैं? Degree of freedom. Okay, ये हमें क्या बताता है? Number of independent, number of independent, number of independent intensive variables, number of independent intensive variables required to fix the state, requires to fix the state. ओके, अब यहां पे P का मतलब क्या होता है? नंबर ऑफ फेजेस. इसका मतलब क्या होता है? नंबर ऑफ फेजेस. ओके, number of phases. Let's suppose, guys, if you are having some matter, okay, it can exist in different phases. जो constituent particle है, they can exist in different phases. Like suppose generally we consider three phases, like solid, liquid, or gas. Okay, there are three phases. Like suppose if you are considering air in this room, if you want to find out DF for air, okay, for air, how many phases you are having? You are having only one phases, because air is existing in gaseous phase only. Okay, but if I will give you a mixture of suppose water, okay, and steam, if you are having some mixture of water and steam, so water and steam, if it is available in some container, so water is in liquid form, steam is in gaseous form, so how many phases are there? There are two phases. Okay, so if in some container you are having liquid water, you are having solid water, means ice, you are having gas also, so how many phases are there? There will be three phases. If I will give you a mixture of water and ethanol, how many phases are there? One phases, because water is also a liquid. Okay, and ethanol is also a liquid, so water and oil, ethanol, both are in one phase only. Get a point? Phases means number of कितने हैं आपके physic, you can say separable constituents हैं. Okay, so there are three phases maximum. Generally we take it three phases: solid, liquid, and gas. So I have given you an example. If you are having a mixture of ice with some other you can say steel ball or something like this, some solid material, so phases कितने होंगे? एक होंगे, solid होगा. Okay, if you are having mixture of water, oil, water oil का mixture क्या हो जाएगा? Again, water and oil, they are having one phases, because oil is also a liquid, water is also a liquid. So mixture of oil, if he will give you a case, you are having a mixture of water and oil, तो कितने DO लोगे वहां पे? So what you will take? You need to take number of phases as one. Okay, because oil, water, both are having one phase. Okay, so F, degree of freedom. P, number of phases. What do you mean by C? Number of components. Number of components. Number of components. Okay, minimum number of components or constituents. हाँ होता है, yes आयुष, I will come to that आयुष, don't worry. F की जगह 2 की जगह 1 होता है, कहाँ पे होता है? I will come to that आयुष, don't worry. So C means number of component. You can write one thing related to that. Like suppose chemically independent constituents. Like suppose you are having any substance. Suppose if I will give you a mixture of some water and oil, suppose here you are having water. Okay, this is water. Okay, and at the top of water, suppose there is some oil. यहाँ पे क्या है? Oil है. Okay, so ये क्या है आपका oil? You are having mixture of water and oil. So these are two different constituents, guys. Oil is a different constituents, different components. Water is a different constituents, different substance. So their component will be what? इनके कंपोनेंट क्या होंगे? देयर कंपोनेंट विल बी डिफरेंट. मींस वाटर क्या है? सपोज इट इज H2O. ओके, अब ये कोई हाइड्रोकार्बन है, कुछ भी है. सपोज ऑयल है, पेट्रोल ले लेते हैं हम, कुछ भी क्या है? इट इज हम हाइड्रोकार्बन. ओके, कोई हाइड्रोकार्बन है. ओके, मिथेनॉल, इथेनॉल, कुछ भी ले लो. ओके, सो दिस इज सम हाइड्रोकार्बन, दिस इज वाटर. सो देयर केमिकली कंस्टिट्यूएंट्स आर डिफरेंट. ओके, यू नीड नॉट टू टेक हाइड्रोजन एज वन, ऑक्सीजन एज वन. इनको अलग अलग नहीं लेना है. दिस इज वन कंस्टिट्यूएंट्स एंड दिस इज हैविंग अनदर कंस्टिट्यूएंट. सो नंबर ऑफ कंस्टिट्यूएंट्स कितने हो जाएंगे? 2 हो जाएंगे. सो इसका मतलब मिनिमम नंबर ऑफ कंपोनेंट्स कितने हैं? दे आर 2. Okay, so if there are different constituents, if there are two constituents, you will take two components. If there are three different constituents, you will take three constituents. Like suppose if there is a mixture of ice, water, and steam, there are three substances: ice, water, and steam. So how many phases are there? There are three phases, because ice is in solid form, water is in liquid form, and steam is in gaseous form. So there are three phases. But how many number of components are there? number of components are 1. Why? Because how you will represent ice? Ice is H2O. It is in solid form, but the chemical formula for ice is H2O. Similarly, what is the chemical formula for water? Again it is H2O. What is the chemical formula for steam? Again it is H2O. So their components are one only, their constituents particle are same. Okay, they are of same form only, they are having different, you can say they are in different phases. So number of constituents will be different when different, they are having different components. Okay, if number of constituents are different, their number of components will be different. Okay, like suppose if I will give you a case of mixture of nitrogen and oxygen. You are having a mixture of nitrogen and oxygen. Like suppose if you will consider air, so air kya hai? It's mostly it is a mixture of nitrogen and oxygen. But what are the number of phases? Number of phases will be 1. What are the number of component, guys? Number of component for nitrogen and oxygen, number of component will be 2, because oxygen is having different constituents, nitrogen is having different constituents. The number of constituents will be 2, but number of phases will be 1. Like this you can write this particular thing for different cases, guys. Mixture of air, nitrogen, oxygen, mixture of air, oxygen and water. Okay, if I will give you a mixture of like that, water, some oxygen is available at the top, नीचे क्या है, water है, तो number of phases भी क्या हो जाएंगे, 2 हो जाएंगे. Number of components will also be different. Getting a point? So अगर constant particles are different, components will be different. Okay, and this 2 is a constant. अब एक बच्चे ने पूछा कि सर यहाँ पे कभी कभी 1 भी होता है. Ayush has asked कि sir sometime I observed कि here is 1 also. Guys, most of the processes like physical processes, I will come to again A44. Okay, आ रहा हूं मैं इस पे. ठीक है, तो sometime we write this expression like this: F plus P equal to C plus 2. Okay, so sometimes, guys, most of the physical processes they carried out under constant pressure condition. Okay, बहुत सारे जो आपके physical processes हैं वो constant pressure conditions में होते हैं. Okay, जब pressure आपने already constant कर दिया, okay, like some water is flowing in some heat exchanger, okay, something like that. Mostly we carried out like boiling, you are carrying out in some container, okay, open container. So in most of the physical processes, pressure is constant. So if you are keeping one intensity property already as a constant, then what you need to do here? So means one property already you have fixed. Okay, now what you need to do? F plus P equal to C plus 1. Okay, so if one intensity property is already fixed, like pressure you have fixed, then what you need to write? F plus P equal to C plus 1. Okay, Ayush? Okay, so DF क्या होता है? देखो मैं इस पे आ रहा हूं. DF का मतलब क्या है? DOF का मतलब होता है डिग्री ऑफ फ्रीडम. इसे बोलते हैं डिग्री ऑफ फ्रीडम. इसका मतलब क्या है, गाइस? सपोज इफ आई विल गिव यू ए कंडीशन हियर. If you are having here, let's suppose if I will give you a case here, you are having water. Okay, you are having ice also, okay, ice, and you are having steam also. Here you are having steam also. Okay, in some container you are having water, you are having ice, and you are having steam also. Okay, so how many number of phases? Number of phases are 3. How many number of components? Number of components are 1. So what is the DUF? DUF will be 0. You can check from this. F plus P equal to C plus 2. Okay, so F plus 3 equal to 1 plus 2. So means F is 0. Degree of freedom is 0. Means in this particular condition, you cannot vary any intensive variable. If you will vary here any intensive variable, the you can say their equilibrium will be disturbed. Okay, so if you are having these 3 equilibrium of steam, ice, and water, these are in equilibrium. Okay, so at this particular point the DF is 0, means you cannot change any intensity property. Like DF means you can change this much number of the intensity property without disturbing the phase equilibrium of that particular system. Again I'm repeating, guys, very important. Ayush has asked, अच्छा किसने पूछा था? हाँ, A47 है. AK47 लिख रहे यार, A47 मजा नहीं आ रहा. AK47 है ना, तो A47 चलो इसका कुछ मतलब हो सकता है. Okay, so what I'm saying, guys, if you're having any system, okay, there are like three different three different phases. So DF represents how many intensive variables you can change without disturbing the phase equilibrium of that system. Okay, if DF is 0, means you cannot change. If you will vary, the equilibrium will be disturbed here. Getting point? So that's why you are having a single fixed temperature. Like if you will take a P versus T diagram, PT, so at a particular fixed temperature, you are getting triple point at a fixed pressure at a fixed temperature. If you want the triple point, you cannot get triple point only by bringing the system at you can say minus zero point 0.1 degree Celsius. Suppose if you want triple point, okay, so this is some container. If you want triple point here, you cannot get triple point only by keep bringing the temperature this. This is not possible. If you want triple point, you need to fix the temperature also. You need to fix the temperature also. Okay. आपको इसको भी क्या करना पड़ेगा, फिक्स करना पड़ेगा. Then only you will get the triple point. Again, I'm repeating, guys. How many intensive variable you can change without disturbing the phase equilibrium? Phase equilibrium is how many phases are there? There are three phases. Okay. अब ये equilibrium है. Equilibrium का मतलब क्या है? Equilibrium का मतलब क्या है? Suppose here suppose you are having here you are having 2 kg water. Okay, you are having 0.5 kg ice. Okay, you are having suppose 0.1 kg steam. Okay, in this particular region, in this particular system, you are having this much water, this much ice, this much steam. If they are in equilibrium, their mass will remain same as long as you are keeping the temperature 0.01 degree Celsius, the pressure 0.611 kilopascal. As long as you are keeping this condition, they will remain in equilibrium, means their mass will remain same. Okay, like suppose after 1 day if you will check, after 2 days if you will check, if you are keeping these things constant, they will remain in equilibrium condition. The water will remain 2 kg, the ice will remain 0.5 kg, the steam will remain 1.1 kg. But it doesn't mean the condensation is not happening here, it doesn't mean the evaporation is not happening here, it doesn't mean the, you can say, the fusion is not happening here. Everything is happening, guys. If you will observe this system continuously, the water is freezing, water is melting also, water is evaporating also, but overall the amount of mass, amount of water which is converting into steam, the amount of water which is converting into ice, the same amount of ice is converting into water, the same amount of steam is condensing into water. Getting my point, guys? So overall they are in equilibrium, their masses are same. But again I mentioned, guys, it doesn't mean there is not any evaporation, there is not any condensation is taking place. Everything is like covering, everything is taking place. Fusion is also taking place, evaporation means vaporization is also taking place, and melting is also taking place, and fusion is also taking place. Okay, but they are in equilibrium. As long as temperature pressure are fixed, they are in equilibrium. And if you will change the these, anyone, if you will change, if you will change the pressure, you will change the temperature, their equilibrium will be disturbed. Equilibrium disturb हो जाएगा तो क्या हो जाएगा? Their mass will change. What, ये तो अगर आपने टेम्परेचर बढ़ा दिया तो क्या हो जाएगा? क्या हो जाएगा? द स्टीम विल कंडेंस इनटू लिक्विड वाटर, या आइस क्या हो जाएगा? मेल्ट होना शुरू हो जाएगा वाटर में. इफ यू विल ब्रिंग हेयर टेम्परेचर सपोज 100 डिग्री सेल्सियस, तो क्या हो जाएगा? देयर इक्विलिब्रियम विल चेंज. दैट इज अ डेफिनेशन ऑफ डी ऑफ आई introduce you. Okay, let me here write some more thing, guys. Let me first show you this particular diagram because this is more very important. Generally हम एक phase diagram show करते हैं, guys, you know. Okay, let me take the screen as black screen. Black screen ले लेता हूँ, white ले लेता हूँ, चलो. हाँ, good. Guys, एक होता है phase diagram. Okay, there is a thing which is particularly known as a phase diagram. What you can say? What do you mean by phase diagram? The graphical representation. Phase diagram होता है एक phase diagram. Okay. Graphical representation क्या होती है? Graphical representation. Graphical representation of different constituent, different phases of a substance. Graphical representation of different phases of a substance, that is known as a phase diagram. Okay, और phase diagram में हम क्या observe करते हैं, guys? What we observe in phase diagram? In phase diagram we observe the conversion of solid into liquid. Transition observe करते हैं. क्या observe करते हैं हम? Phase transition. We observe the phase transition. Transition क्या observe करते हैं? Phase transition means solid to liquid, liquid to gas, how the phase is changing. So phase diagram क्या है? It's a graphical representation of different phases of a substance, and in phase diagram we observe the phase transition, means phase का कैसे change हो रहा है. अब उसमें कुछ चीजें हैं which you need to remember guys. अब देखो मैं पहले लिख देता हूँ melting. Okay, melting का मतलब क्या होता है? Conversion of solid to liquid. Solid से liquid को हम क्या बोलते हैं? Melting. Solid to liquid is known as melting. Similarly, what is condensation? Condensation क्या होता है? Vapor to liquid. Vapor to liquid. Okay, vapor to liquid. Melting क्या होता है? Solid, liquid to solid, solid to liquid. Solid to liquid क्या हो जाएगी आपकी? Melting. Okay. Condensation क्या होगा? Vapor to liquid. Okay. Similarly, if I will write here vaporization, यहां पे लिख देता हूं मैं vaporization. Melting का रिवर्स क्या होगा? Melting का रिवर्स होता है fusion. Fusion. Okay. Fusion क्या होता है guys? Liquid to solid. Liquid to solid. That is known as fusion. Okay. Condensation का उल्टा क्या हो जाएगा? That is known as vaporization. Vaporization. Okay. Vaporization का मतलब क्या होता है? Vaporization means liquid to vapor. Liquid to vapor, that is known as vaporization. Fusion, vaporization, melting, condensation. अब इसमें एक और चीज आती है, ओके, उसे बोलते हैं सबलिमेशन. ओके, ये एक इंपॉर्टेंट वर्ड है जो पूछ लेता है कई बार, वो सबलिमेशन. ओके, सबलिमेशन इसे क्या बोलते हैं? डायरेक्ट कन्वर्जन ऑफ सॉलिड टू वेपर. सॉलिड का वेपर में जो डायरेक्ट कन्वर्जन होता है, दैट इज नोन एज सबलिमेशन. ओके, जनरली दैट थिंग वी ऑब्जर्व फॉर ड्राई आइस. जो ड्राई आइस होता है ना, सॉलिड कार्बन डाइऑक्साइड, सॉलिड CO2, जिसे हम बोलते हैं ड्राई आइस. क्या बोलते हैं? ड्राई आइस. ओके, सो इफ यू विल टेक ड्राई आइस, लाइक सपोज अगर मैं आपको ड्राई आइस दे दूं, ओके, इफ यू विल पुट ड्राई आइस हियर, ओके, ड्राई आइस मीन सॉलिड CO2. अगर आपने ड्राई आइस यहां पे रखा, हालांकि आप यू कैन नॉट पुट दैट ड्राई आइस into your hand directly, because if you will keep here dry ice, it will quickly convert into vapor. There will be no conversion from solid to liquid first. Directly the solid solid CO2, solid carbon dioxide, it will convert into vapor. Okay, that is known as sublimation. इसे हम क्या बोलते हैं? Sublimation. And when sublimation will take place, huge amount of heat that substance will take up from your hand, guys. Yes or no? Because for sublimation, like when a solid is converting into vapor, it is taking huge amount of energy, because it is taking the you can say, like suppose if you will consider the conversion from solid to liquid, liquid to vapor, so huge amount of energy, that is known as that generally here, if you will take solid to liquid, what we need to take? We need to take here the latent heat of fusion. Here what will take? We take the latent heat of vaporization, guys. Here and here, in both cases, here the latent heat of HFG, कौन सी, इसे कौन सा बोलेंगे हम? या लेटेंट हीट ऑफ क्या बोलेंगे? लेटेंट हीट ऑफ फ्यूजन. ओके, और यहां पे क्या लेंगे हम? लेटेंट हीट ऑफ वेपराइजेशन. और यहां पे क्या लेंगे हम? लेटेंट हीट ऑफ सब्लिमेशन. ओके, एंड यू नो गाइज, लेटेंट ऑफ सब्लिमेशन इज वेरी हाई. सो व्हेन the dry ice will convert into vapor, it will take a huge amount of energy, because latent heat of sublimation is very high. So that energy it will take from your ice, and due to that, guys, the temperature of your hand will drop to very low value, and that can damage your body cell actually. Okay, so we cannot keep that solid ice directly on your hand. If you will keep this part, the some part, here the body cell will be damaged. Okay, so that's why we don't carry out this particular thing. If you want to put a dry ice in your hand, you need to wear special type of gloves actually. Okay, so these directly things also you can remember, guys. This is known as a PVT surface. इसे क्या बोलते हैं हम? This is known as a PVT surface, because we are representing here the pressure line. Okay, here the volume line, we are representing here volume. Okay, and here, guys, we are representing temperature. This particular 3D representation, this is known as a PVT surface. प्रेशर, वॉल्यूम एंड टेम्परेचर. अब ये नहीं देखना है आपको, आपको सिर्फ याद क्या रखना है? इन पीवीटी सरफेस, गाइज, पीवीटी सरफेस पे, पीवीटी सरफेस पे, या पीवीटी जो डायग्राम होता है वाटर के लिए, जनरली हम वाटर के लिए शो कर रहे हैं, जो क्रिटिकल पॉइंट होता है आपके पास, जो क्रिटिकल पॉइंट होता है वो तो क्या होता है? पॉइंट होता है. क्रिटिकल पॉइंट क्या होता है? पॉइंट होता है. बट जो ट्रिपल पॉइंट होता है भाई, ट्रिपल पॉइंट इज अ लाइन. पीवीटी सरफेस पे ट्रिपल पॉइंट क्या होता है? लाइन होता है. यू कैन ऑब्जर्व हियर गाइस, this is the triple point guys. This particular condition, this particular line is known as a triple point. So on PVT surface you are having, Varad, you need to not to remember this. आपको ये remember नहीं रखना है. Separately, you can remember PT diagram and PV diagram. I will show you that PV and PT diagram. अब ये किसी को भी remember नहीं करना है, but just remember this particular curve, guys. Look, suppose if I will ask you, what is this curve? ये कौन सी curve हो जाएगी? ये वाली curve कौन सी है? ये वाली curve को क्या बोलोगे आप? This is known as vaporization curve because liquid is converting into vapor. What is this? इस कर्व को क्या बोलोगे? So like ये वाली कर्व होगी, solid is converting into liquid. What is that? That is known as a fusion curve. Okay, so fusion curve, this is the fusion curve, this is the vaporization curve. Okay, again what is this? इसको क्या बोलोगे? This is so this is known as fusion. Again this is known as fusion because liquid किसमें convert हो रहा है? Solid में. Fusion. इसको क्या बोलोगे? This is known as melting. तो बस इतना याद रखो. Okay, you need not to remember the entire diagram. Okay. Three dimension क्यों है? Because we are taking three variables: pressure, volume, and temperature. We are taking P, V, and T both. But if you want to show only two, you can show. You can have this diagram on PT surface also. Like suppose if I show this part, what I want to say, guys, like why we are having this curve. So if you will observe this part only, guys, if you will observe only this part, if you will observe only this part, guys, P versus T. So if I will hide here, if you will just hide this part, and if this particular thing, if you will observe from this side, so what you will get, guys, you will get a line, something like this, and then a curve like this. Okay, so that's why you are, if you will represent this particular thing on a PT diagram, you will have some graph something like this. Okay, so you will have a graph something like this. Okay, so this type of curve you will get, and this is your triple point. Okay, this is your triple point on PT diagram which I have shown you guys here. So this type of curve you are getting. Okay, and this is for water actually. Okay, so for different substances, like suppose this curve which I have shown you guys, this is for mostly compressed liquid, mostly compressed liquid. Like this chart, this particular chart which I have shown you guys, this chart. Okay, this is not for water, this is for all substances which are generally compressed liquid. Compressed liquid का मतलब क्या होता है? The substances which generally contract when there is a decrease in temperature. Mostly substances, most of the substances, they generally contract when there is a decrease in temperature. But water is the exceptional case, guys. Water actually, water expand when there is a decrease in temperature, because water density is maximum at 4 degrees Celsius. Okay, so water के केस में उल्टा होता है. Like suppose if you take ice at 0 and ice at some low temperature, what you can say, the density of ice at 0 degrees Celsius, it is less. Okay, that's why ice will float at the surface of the water. Okay, water density is more as compared to the ice. Okay, what you can say, so but ice is in solid form, water at 0 degrees Celsius. Okay, if you are having water, it is having less density as compared to the density of ice. Okay, so what information you can get, guys, from this? This is the particular curve for compressed liquid, but for most of the liquid, guys, this type of curve you get. But for water, you will get curve like this. Water के लिए curve कैसी मिलती है? ऐसा मिलती है. This is for water, guys. This type of curve you will get for water. Okay, this is known as a triple point. इसे क्या बोलते हैं हम? Triple point. This is the triple point. Okay, so in this particular diagram, guys, which is shown to you, this is for water. Okay, and here what you are having, this is known as what? Ice to water क्या हो जाएगा? That will be melting. Okay, water to ice क्या हो जाएगा? That will be fusion. और इस कर्व को क्या बोलोगे आप? इस कर्व is known as fusion curve. इस कर्व को क्या बोलेंगे हम? Fusion curve. इसे क्या बोल देंगे हम? Fusion curve. Okay, water is converting into vapor, तो इस कर्व को क्या बोलोगे? This curve is known as what? This curve is known as vaporization curve. Similarly here, this curve is known as sublimation curve. Why? Because solid is directly converted into vapor. Okay, like this you can remember: fusion curve, vaporization curve, and this is sublimation curve. Okay, so what I told you guys, if you are representing PT diagram, you are having triple point as a point only. Okay, but if you will draw the PV diagram, guys, अगर आपको PV diagram draw करना है, like if I will show you here the PV diagram, the PV diagram will be something like this, guys. PV diagram will be something like this. This is the PV diagram, guys. Okay, so if you will observe this, this is pressure, this is volume. So how to observe this diagram? You will observe from this side. So what you will get? You will observe this line, this line, this line, this curve. Okay, so you will observe the PV diagram something like this. Okay, so this is pressure, this is volume, and this is PV diagram for water. Okay, so on PV diagram of water, what you are getting, you are having critical point as a point only, but what you are getting, you are getting triple point as a line. ये क्या बता रहा है आपको, triple point. This is the triple point, guys. Okay, and this is your solid, this is solid plus liquid, and this is your liquid region, this is liquid plus vapor, and this is your vapor. This is known as saturation curve. This is also saturation curve, this is also the saturation curve. इसे भी क्या बोल रहे हैं हम, saturation curve. And this particular point where this particular saturation curve, okay, for this liquid, okay, this is for vapor, okay, ये जहां पे मीट करेगी, दिस इज नोन एज क्रिटिकल पॉइंट, एंड दिस पर्टिकुलर रीजन इज नोन एज क्रिटिकल सुपर क्रिटिकल रीजन. इसे क्या बोलते हैं हम, सुपर क्रिटिकल रीजन. Okay, the fluid present in the supercritical region, that is known as supercritical fluid. Any fluid which is present in the supercritical region, that is known as supercritical fluid. अब देखो आपको समझना क्या है, what is the difference between triple point and critical point? Critical point is that point of particular substance. Critical point you can define for any substance, guys. You can define it for oxygen, you can define it for water also, you can define critical point for any substances, you can define triple point also for any substances. What is the difference in critical point? In, let me write here, guys, so that you will get the clear cut comparison. Triple point, critical point. Okay, triple point pe how many number of edges? Number of edges are 3. Critical point, how many number of edges? Generally we take number of edges at 2. Number of edges we will take at 2 only. Okay, so suppose if you are writing these for water, अगर मैं किसके लिए लिख रहा हूँ, water के लिए, if you are writing this for water, so number of component कितने हो जाएंगे, number of component will be 1. Here also number of component will be 1. Okay, so here if you will use the Gibbs phase rule, F plus P equal to C plus 2, so F will come out to 0. Okay, here also if you use this F plus P equal to C plus 1, this is actually at critical point you cannot effectively define the DUF. Critical point where you cannot define effectively. Okay, some of the people, they generally represent this particular DUF for critical point with this expression F plus P equal to C plus 1. Okay, so here again you will get F equal to 0. Okay, so if you want to use this particular expression, अगर आप भी यही वाला expression use करना चाहते हैं, so you can write here F plus P equal to C plus 2, but you need to take phases 3. आपको phases कितने लेने पड़ेंगे, 3 लेने पड़ेंगे. F plus 3 equal to 1 plus 2, so again F will come out 0. So how many, like if you will take this, तो कौन से 3 phases define करोगे? One is supercritical vapor, second one is supercritical liquid, and third one is supercritical fluid. So some of the people they defined the DUF at critical point with this formula, guys. Okay, and they have considered number of phases as 3. कौन से 3 phases ले लिए उन्होंने? Supercritical vapor, supercritical liquid, and supercritical fluid they have considered, but that is also not right. Some of the people, they considered this formula F plus P equal to C plus 1. They considered there are 2 phases, okay, liquid and vapor, F plus P equal to C plus 1, and they defined F is 0 because we are getting a critical point as a single point only. Critical point, there is a particular fixed characteristic of a particular system. We are having a fixed critical point. Like for water, if you want to represent water के लिए जो critical point होता है, water के लिए जो critical point होता है, that is close to 373 degree Celsius. Close to 373 degree Celsius, 373.69 होता है कुछ, तो इसको 374 भी you can write, 374 भी आप लिख सकते हो. Critical point जो pressure होता है, this is temperature. Pressure अगर आप लिखना चाहो, pressure critical point, pressure at critical point. Okay, so that is close to 1 बार, 221 बार के आसपास होता है. या इसको अगर आप लिखना चाहोगे तो आप लिख सकते हो क्लोज टू 218 एटमॉस्फेरिक, 218 एटमॉस्फेरिक. ओके, 220 बार लिख सकते हो, 221 बार लिख लो, और 218 एटमॉस्फेरिक. एग्जैक्ट वैल्यू इफ यू वांट, लेट मी चेक इफ आई एम हैविंग. Okay, no, I'm not having. Okay, so yes, 22.06 megapascal. This also you can remember. 22.06 megapascal. This is the information which you can remember. Okay, 22.061 megapascal, and you can write it as 217.7 atmospheric. ये भी लिख सकते हो. Exact लिखना चाहोगे तो ये लिख सकते हो 217.7 atmospheric. मतलब एटमॉस्फेरिक प्रेशर का कितना टाइम, एटमॉस्फेरिक प्रेशर का 217.7 एटमॉस्फेरिक टाइम, जनरली वी राइट इट 218 एटमॉस्फेरिक। और अगर बार में लिखना चाहोगे तो बार में क्या हो जाएगा, इट विल बी क्लोज टू 221 बार, क्लोज टू 221 बार। एवरीथिंग इज राइट, सभी ठीक है। 221 bar, this is also right. 217.7 atmospheric, this is also right. 218 atmospheric, 222.06 megapascal, this is the critical point of water. अब देखो critical point को समझो, how we can define critical point, how we can define critical point. So guys, critical point means generally if you are having a mixture of water and vapor under some at any temperature and pressure, you can condense steam by only changing the pressure. So suppose if I will give you a mixture of water and steam, you can condense that steam only by changing the pressure. Okay, so suppose you're having a water steam mixture at some temperature, suppose 150 degrees Celsius, at some pressure, suppose 100 bar. If you want to condense that steam, you can condense only by changing the pressure. But above the critical point, you cannot condense the steam only by changing the pressure. If you want to condense, you need to change both temperature and pressure. So that is a some definition of critical point. So what you can say, at critical point there are two phases. Okay, and at critical point directly that particular liquid is converting into what, that is converting into steam. Okay, and actually this is a more effective way, guys. Just remember this. If anybody will ask you what is a critical point, so what you will say, sir, at critical point there are two phases, like critical vapor and critical liquid, and both are having almost same density. Okay, so this is that particular point for a particular substance at which the liquid and the fluid, liquid and vapor, both will have equal density. Okay, so they are not actually separable, they are not distinguished. You cannot distinguish between solid and liquid. Okay, so when you cannot distinguish between solid and liquid, what you will say, that particular point is known as the critical point. Okay, I think now you are getting what is the critical point. So what you will say, at critical point, the critical point पे क्या हो जाएगा, इस जो ये critical point था, इस critical point पे, at critical point the density of vapor, that is almost equal to the density of liquid. Okay, you cannot distinguish between लिक्विड एंड वेपर, आप उनके बीच में फर्क नहीं कर पाओगे, एंड जब आप फर्क नहीं कर पाओगे तो उस पॉइंट को क्या बोलते हैं, दैट इज नोन एज अ क्रिटिकल पॉइंट. एंड इफ यू आर हैविंग ए फ्लूइड, if you are having any substance above the critical point, you cannot condense that gas or vapor phase ko, you cannot condense directly into liquid only by changing the pressure. If you want to condense any substance, like suppose if you're having steam above the critical point, like suppose if you're having supercritical steam, you cannot condense supercritical steam only by changing the pressure. If you want to condense, you need to change both pressure and temperature. Remo, what do you, I'm not getting your point. Okay, so I think this is now clear to you what is a critical point. And yes, so now guys we can solve some questions. I am here with some 5-10 questions in front of you. एक रेजिस्टेंस थर्मोमीटर होता है, बच्चे मैं यहाँ लिख देता हूँ, रेजिस्टेंस थर्मोकपल, मैंने इसके बारे में जिक्र नहीं किया. रेजिस्टेंस थर्मोकपल, थर्मोमीटर, रेजिस्टेंस थर्मोमीटर किस पे वर्क करता है, इट वर्क्स ऑन द वी स्टोन ब्रिज प्रिंसिपल. Wheatstone bridge प्रिंसिपल. ओके, और इसमें क्या होता है, इस प्रिंसिपल पे क्या होता है, द रेजिस्टेंस इज द थर्मामीट्रिक प्रॉपर्टी. रेजिस्टेंस क्या होती है आपकी, रेजिस्टेंस इज द थर्मामीट्रिक प्रॉपर्टी. रेजिस्टेंस इज द थर्मामीट्रिक प्रॉपर्टी. Let me check if I am having this diagram of this, otherwise I will draw. Yes, okay, चलो, तो ये कुछ ऐसा होता है. Let me write here, suppose so this, there are something like this. Let me show you. Yes, so something like this. Okay, so what you are having in a thermistor, this is also known as thermistor. इसे क्या बोलते हैं, thermistor. Okay, thermistor में चार रेजिस्टेंस होती है, like suppose P, QRS. These are the four resistance. Okay, ये क्या है? This is a variable resistance. This is the variable resistance. This will change if you will change the temperature. The temperature if you will change, the resistance will change. Okay, because you know for any metal, the resistance क्या होती है? The resistance will change with the temperature. Like suppose you are having some relationship, something like this. Okay, so these are constant, alpha, beta are constant. So if you are changing the temperature, the resistance of a metal wire will change. Like suppose if you are having copper at some low temperature, its resistance will be low. If you are having copper wire at high temperature, its resistance will increase. Okay, so that's why I will come to that again. Don't worry. So if you are changing the temperature, the resistance will increase. And this particular change in resistance you are measuring, guys. This resistance you are measuring, this we are measuring. This change in resistance we are measuring. Okay, and by measuring this change in resistance, we are defining the temperature. Okay, this is a just principle of Wheatstone bridge. This is only sufficient for you guys. Don't worry about that. Thermistor works on Wheatstone bridge principle, and with this particular principle, guys, we are measuring the change in resistance, guys. This resistance we are measuring, which is actually changing with the change in temperature. And how it is changing, guys? Actually, you are bringing this particular resistance to somewhere. Like suppose if you will bring this body, suppose here is some hot container, something like that. Okay, here is some hot container in which you are having some hot fluid. Okay, you are having some hot fluid, some hot water. Okay, so when you will bring this resistance into some hot fluid, so this resistance will change or not? Yes, yes, it will change. Okay, so when it will change, you are measuring that change. By measuring that change, you are defining the temperature, because you know temperature क्या है? We are not measuring temperature here, we are measuring the change in resistance. That's why we are saying कि resistance is the thermometer property, because we are measuring the change in resistance only. Okay, by measuring the change in resistance, we are defining the change in temperature. Okay, so this is just basic things about resistance, thermometer और thermistor. So thermistor, thermometer, constant volume, constant pressure का भी आप ऐसे आइडिया लगा लो कि constant pressure में what we are doing, we are keeping the pressure constant and we are measuring the change in volume. By measuring the change in volume, we measure the change in temperature. Okay, so now guys, let me show you some of the question. Let me save this, guys, because बच्चे मांगते हैं और मैं इसको सेव नहीं कर पाता, थोड़ा सा टाइम लगेगा. एंड आफ्टर दैट आई कैन टेक सम ऑफ योर डाउट, गाइस. 2 मिनट लगेगी इसमें सेव होने में. ओके, इन द मीन टाइम आई कैन टेक योर डाउट. जल्दी जल्दी में मैं इसको अवॉइड कर देता हूँ सेव करना, एंड दैट्स व्हाई आई एम some most of the time I will be not able to share that. But yes, I will try from today only. I will try to save this particular PDF and I will share with you. Don't worry. You will find this entire PDF of this also, and with some question also. 8 to 10 questions you will find uh, in next half an hour on YourPedia group only. Yeah, if you are associated with us. Yes, guys. Any doubt if you are having, you can ask. I can take some of your doubt. Ashish is saying, how can I contact you or Vijender sir? Ashish, just you can go to YourPedia website. If you will go, you will find some number on that particular website, and by calling on those numbers, you can request, sir, I want a number of Vishal sir, I want number of Vijender sir. You will get some contact. Surely you will get. Okay. And if you're associated with us, like suppose you have joined that some gate preparation or any type of module, so then yes, you very easily you will get. Satish, what do you mean by negative temperature? Negative temperature से क्या मतलब है? If suppose if you want to measure negative temperature, negative से क्या मतलब? डिग्री सेल्सियस में आप टेम्परेचर मेजर करना चाह रहे हो? Okay, so there are different type device. Like suppose the thermometer which we are having, that is having a range. एक range होती है. For different type of temperature measuring devices, there are different range. So thermocouple you can use. Like suppose there is a particular thermocouple which is developed for some particular range. For suppose from -40 to 150. Okay, -40 to -50 to 150. So there are different design. Like these type of instruments only we use, like constant gas. Okay, you can use constant volume gas thermometer for measuring the negative temperature. You can use thermocouple also. Okay, if there is a temperature difference, EMF will set up. Getting point? So but it depends, like what is the range of that thermocouple. So there are different thermocouple which are available for different range. There are different gas constant volume gas thermometer available for different range. Getting point? You can use a thermocouple under different ranges. Okay, so it is not like that ki sir can I use that Yes, you can develop a constant volume gas thermometer for measuring the negative pressure also. Okay, so let me now take some of the question, guys. So yes, चलिए तो पहला क्वेश्चन आपके पास आ रहा है बच्चे, बड़ा सिंपल क्वेश्चन है, एंड दिस इज फ्रॉम लाइक वन ऑफ द स्टूडेंट एक्चुअली आस्क्ड मी, सर व्हाट इज द एश्योरिटी की these questions are from HPCL, guys. Oh, guys, yes, what I can say, guys, we found these particular papers, HPCL papers, from website only, guys. Okay, but yes, these we cannot assure you, but they are from HPCL because those papers which we actually find out, they are very old, like close to 10-15 years old, so we can actually rely on those particular papers. Okay, but yes, there is no such 100% proof, but we can rely on those paper. And yes, parallelly we are solving lots of other similar level questions also, guys. Okay, so here when I'm saying HPCL, this is from HPCL based on that relevant source. Okay, from which actually we downloaded those particular papers. Okay, and yes, in future I will try, because lots of students of YourPedia, they are actually doing job in HPCL also. So we will try to contact them also, and if we will found some relevant papers from that particular organization, it will be more useful, more beneficial for us. So surely we will try for that also. Ashish Mishra is saying, आशीष अच्छा, बच्चे A47 का डाउट था, यूरोपीडिया की वेबसाइट पे भी सेम कोर्स है। देखो, let me tell you very simple thing, guys. If you really want to prepare for any competitive examination, guys, you cannot entirely prepare just by watching some of the part on YouTube, guys. Okay, so if you want to prepare for any particular course, you need to cover entire domain, you need to cover entire thing. Okay, and you, like, you all are mature, guys. It is not easy for any organization to cover entire module on your on website open. We cannot actually cover we cannot cover entire module on your YouTube, you know. Okay, so there are some limitation. Part we are covering, but entire only 10 20 20%, guys, not more than 10-20%. Okay, so if you really want to prepare, you need to purchase that entire module. As you purchase, you will find lots of videos on panel, recorded videos also, and live class also. We are starting from 19th of March. Okay, yes, the detailed schedule already we have shared on your on the particular WhatsApp group. Okay, you will find a particular system, a schedule you will find, and lots of classes on daily basis we will conduct on YouTube, and we will conduct on mostly classes we will conduct on Zoom. Through live classes we will conduct. Okay, so if you really want to prepare, you need to purchase that package. How to purchase? One of the student asked me, वेबसाइट पे यही सेम कोर्स है, बट only YouTube you are having 20%. Entire course is available on YourPedia panel. If you will go, you will find on PSU basically column. Go to YourPedia website, you will find the link, and you will find the link in description of this particular video also. So the process of converting ice directly into steam is sublimation. बहुत आसान क्वेश्चन था, and you most of the students have easily answered this. Let us move to, guys, next question. नेक्स्ट क्वेश्चन पे आते हैं, मैं जल्दी से 2-3 क्वेश्चन ले लेता हूं। चलिए, सो दिस इज द सेकंड क्वेश्चन, गाइस. This is the second question, and I am placing in front of you third question also. So there are two questions in front of you. Try to answer. Gives phase rule for binary phase diagram. Binary phase diagram. ठीक है, अब इसके लिए क्या आंसर हो जाएगा? It will be 1. It will be F plus P equal to C plus 2. No, calculator is not allowed. Calculator is not allowed. Okay. Zeroth law of thermodynamics states that two thermodynamic systems are always in thermal equilibrium with each other. ये तो कोई सेंस ही नहीं बना. If two systems are in thermal equilibrium, then the third system will also be in thermal equilibrium. ये भी कोई मतलब नहीं बना. Two systems not in thermal equilibrium with the third system are also not in thermal equilibrium. When two systems are in thermal equilibrium with a third system, they are in thermal equilibrium with each other. So option D is right. Option D is right. Okay, these type of question, guys, you will find in PSU. Okay, let me take some more question. Try to answer this, guys. Question number 4 and 5. A temperature, consider the following statement. A temperature scale defined in terms of some physical property of a material is called empirical scale. Properties of material to nahi, we are the temperature scale, they are independent of the construction of the material. Okay, so this is not right. Material पे ऊपर नहीं depend करते. This is right. No, this is wrong actually. The Kelvin temperature scale has been defined with respect to triple point of water, which is assigned a value 0.01 degree Celsius. So ये ठीक है. This is right. The ideal gas thermometer, ideal gas temperature scale does not depend on the nature of the thermodynamic material. This is also right. Okay, so 2 and 3 are right. What will be the right option, guys? Option B will be the right option. In thermodynamic analysis, a pure substance का मतलब क्या होता है, guys? Which is homogeneous in chemical composition, which is homogeneous in chemical aggregation. Okay, like suppose if I will give you a in some container you are having nitrogen. Okay, in some container, suppose, let me show you here. In some container you are having nitrogen, some container you are having water. Okay, so both are pure substances because they are homogeneous in chemical composition, they are homogeneous in chemical aggregation. This is container 1, this is container 2. Okay, but suppose, guys, if I will take you a if I will take a just some container in which water is available and steam is also available. Okay, suppose water and oil is there. यहाँ पे क्या है, water है, यहाँ पे क्या है, oil है. Okay, this is water, and suppose at the top of water you are having oil. So can you say this is a pure substance? No, because they are not homogeneous in chemical composition. So their chemical composition is not same. So this is not a pure substance. This is not a pure substance, but these are pure substance. Okay. So any pure material, like suppose pure copper, pure aluminium, pure nitrogen, pure water, they are pure substances. Mixture of substances can also be a pure substance. If you're having a mixture of gases, like suppose in air is a mixture of various gases, so air also qualifies for a pure substance. Okay, because all those mixtures, they are like their composition is uniform throughout. Like suppose if you will take this part of air and like from any other corner of the room, if you will take another part, they're chemically they are homogeneous. Okay, so their composition is uniform throughout. Okay, so that's why air also qualifies for a pure substance. Why? Because the chemical composition is same throughout. But why oil and water mixture is not qualifies for pure substance? Because the composition is not same, guys. Getting point? Oil is lying at the surface of the water. So if you will take some sample from this place, and if you will take sample from the surface, their sample will be different. So getting point, guys. Why air is a pure substance? Because the chemical composition is same everywhere. But here the chemical composition is not same. Okay. Similarly, if you will take a mixture of water, steam, and गैस सपोज अगर या वेपर का अगर आप ले लेते हैं तो दैट आल्सो क्वालिफाइज फॉर ए प्योर सब्सटेंस. एक्सपोज हेयर इफ यू विल टेक वाटर, वाटर ले लेते हैं या ले लेते हैं आइस. ओके, या ले लेते हैं स्टीम. तो स्टीम, आइस एंड वाटर. So they are also we can consider. Okay, getting point, guys. So what you need to understand, pure substance has no dissolved impurities. ये तो नहीं है. Consists of only a single species, may have a number of chemical species, but the composition remain constant, behave as a perfect gas. This is wrong. Okay, may have a number of chemical species, but their composition remains constant. This is right, guys. Okay, why? Because we are I told you, guys, different component may be there. Like this is a single component, this is a single component, but combination of different components can also qualifies for a pure substance if their composition is constant and it is uniform throughout. Okay, like air. Suppose, guys, if you will take an example of air का mix example ले लेते हैं या N2 ले लेते हैं. Okay, so N2 क्या is the pure substance. So number of edges are 1, number of components 1. So if you will check DUF, it will come out 2. If you will check out DUF, it will come out 2. That is known as a two property rule. इसे क्या बोलते हैं? Two property rule. This is known as a two property rule. Means if you want to draw any ideal any air standard cycle like Otto cycle, diesel cycle, so two properties are required to fix the state of a system. Two intensive variables are required to fix the state of system. Like because for any single phase substance, single phase, single component, single phase, single component substance, the DF is 2. directly also you can remember. And this is known as a two property rule. Let me take here some more question, guys. चलो इसको ठीक करना पड़ेगा. I'm not taking this question. Try to answer this, guys. Try to answer this question. So two questions are in front of you. For a mixture of solid, liquid, and vapor, phase of a pure substance in equilibrium indicates the number of independent intrinsic property needed to be. अब ये तो solve करने की जरूरत ही नहीं है, zero. Because जब तीनों phase exist कर रहे हैं, solid, liquid, and gas, solid, liquid, and gas all are existing for a pure substance in equilibrium indicates DF will be zero. Directly we've obtained that expression for triple point of water. Okay, for a single component, two phases mixture, the number of independent variables will be single component hai, means C equal to 1, two phases P equal to 2. Just use the formula F plus P equal to C plus 2. So F will be F plus number of phases are 2 equal to 1 plus 2. So DF will be 1. DF will be 1. Very simple, easy question. Okay, let me take some more question, guys. So two more questions are in front of you. Which one of the following is a fluid whose properties in all its three phases are made use of thermodynamics? Means thermodynamics में जिसकी properties को हम use करते हैं, किसकी property को use करते हैं guys? ये तो बहुत आसान question है. We use the properties of water. We generally define specific heat of water, latent heat of water, latent heat of fusion of water, triple point of water, ice point of water, steam point of water. So most of the property in thermodynamics we made use of water. Okay, so answer क्या हो जाएगा? Option D. Okay, on PVT surface, on PVT surface, the triple point and critical point are seen respectively. The triple point and critical point. अब critical point क्या होता है guys? PVT surface पे critical point क्या होता है guys? ये point ही होता है. Okay, critical point क्या होता है? Point होता है. Triple point क्या होता है guys? Triple point होता है line on PVT surface and on PV diagram. PV diagram पे and PVT surface पे you will find a triple point as a line. You will find a triple point as a point only on PT diagram. If you draw the PT diagram, you will find a triple point as a point. Otherwise, on PVT diagram and PV diagram, you will find triple point as a line. तो आंसर क्या हो जाएगा? Line and point, line and point, line and point. Yes, D will be right answer. Option B will be the right answer. Okay, so कुछ इस तरह के क्वेश्चन है guys. We discussed. These are the very basic simple question from thermodynamics, guys. So now if you will watch that lecture one which is available on YourPedia panel. Okay, and if you will go through this also, you will able to solve basic questions, basic problems related to this particular subject, thermodynamics. Next class, guys, we will start with energy interaction. So we will discuss what is heat, what is work, and next class, next to next class, we will introduce about first law, second law. So slowly we will cover this entire subject. Okay, and you will able to extract important concept of this particular subject, guys. So in numerical point of view, we will not go into more you can say difficult numerical or difficult concept thing, but concept wise we will discuss every single concept which is required in all type of different type of competitive examination. So conceptual we will discuss everything. Numerical point of view, I will take up only those problems which are relevant for this particular examination, guys. Getting point? So I'm not here going to discuss like problem which were asked in gate or any other examination. I will discuss problem only which were asked in PSU like SSC, engineering services, or other what you can say similar level of examination like HPCL or other examination. Okay, so let's meet in next class. Thank you very much. Thanks for watching. Okay, any doubt, any problem if you are having, you can ask. So I'm here again in front of you in next for next 1-2 minutes. So any doubt if you're having, you can ask, guys. Anything if you want to ask, you can ask. Chali. Okay, no doubt, no problem. हाँ, yes, Sandeepan. Triple point is a point for PT curve. Pressure versus temperature curve. You will get a triple point as a point. हाँ, बिल्कुल मिलेगा भरत. I will share some questions for practice. Surely I will share, Bharat. Don't worry. Okay, guys. Thank you very much. Good day.